What you're looking at here in front of you are two Tesla turbines, one of which, this one here, should be pretty familiar to all of my subscribers. This guy here has been producing power in my hydroelectric plant for about 7 years, and it has just functioned incredible. I get constant power out of this thing. It has never failed, ever. I've never really had to replace any of the parts in there. It still has the original bearings, everything that came with the original motor that we stripped apart to create that Tesla turbine. Over here on the left, you can see is a 3D printed Tesla turbine that I made 2 years ago. This was printed out of a PETG Pro, I believe is what we used to build it. Now this turbine has been producing power right beside this one inside of our hydroelectric plant for about 2 years now. Just the other day it finally stopped working. The 3D printed bushings finally gave out on it and it just quit. So what we're going to do today with this one is I'm going to pull it apart, take a look at it, see where it failed. Then we're going to take our more advanced 3D printer systems that we have today than what we had then, and we're going to rebuild this turbine out of a much better material. What we're going to build the new one out of is a high temperature polyamylene or nylon carbon fiber material. That material should last for many years. Even though we got 2 years out of this, which is way more than I ever thought this thing would ever last, I do expect the new one, built out of these new high temperature, high strength materials, to even last longer. We're going to go ahead and do some maintenance here today on our old one to put right back into our hydroelectric house, just to get that thing back up and running, since my entire facility here runs on alternative energy. We've got 6,000 watts with the solar panels, we've got 3 different hydroelectric generator systems, and I've got a bunch of wind generators out there, which someday I'll bring you out and I'll show you what we've got going on. But today what I'd like to do is, first of all, let's go ahead and just strip this thing down, since it finally gave up its ghost. Let's see what it looks like. Alright, so there's the internals of it. Look at that, actually. Looks like all the blades, looks like they all held together just fine. I don't see any damage whatsoever on the blades, which is pretty impressive considering that is just made out of PETG, which is a strong material, but it's not considered an engineering grade material. So you can see here, let me go ahead and bring that up to the camera for you. A little bit of water still on there. Let's go ahead and rub some of that off of there. But you can see it's actually held together pretty well. And the fact that it's been running in water instead of air or steam or something like that, it's the only reason that the 3D printed parts have probably lasted as long as they have without wearing out. That water acts as a lubricant and also reduces the heat generated through the friction through those 3D printed bearings or bushings, if you want to call them that. Let's go ahead and see if we can get this other side off of here. There we go. You can see right there one of the 3D printed bushings that have been making this thing work all this time. It finally seized up and created a welding spot in there. Potentially we had a drop in our water pressure and maybe allowed this to dry out just a little bit as it was spinning. After that many years, that's pretty impressive for PETG. Let's go ahead and set that aside. Let's take a look at inside the case here. The case itself looks like it's suffered no damage whatsoever. Actually looks like it's in pretty good shape. You can see all the end caps here. Now one thing we're going to do differently is that we're only going to put holes in one side. I've noticed that during the last couple years of using this that the holes on the other side are actually probably hindering the output instead of helping it, because it's allowing some of the water to go the other direction. And I think that's actually creating some eddies or resistance points within the flow that's limiting its power just a little bit. So we may get rid of one of these sides with the holes and just make a completely sealed up side, just like the one we have here, which has only holes on one side. This thing has just kept running year after year, produces constant power out there in the hydroelectric shed. I just want to crack it open and do my yearly maintenance on it. And take a look to make sure none of the blades have failed, there's no junk stuck between the blades. We're going to add some oil and some grease in there just to prolong the life of this. And let's go ahead and first give that a spin. And I do hear what sounds like maybe a piece of sand or something got in there and is rotating around with the blades. We'll find that when we open it up. Let's go ahead and crack the case and see what it looks like. Oh yeah, that's been sealed for a while. Alright, give me just a second here. Let's see how it does. Alright, well there we go. Let's take a look inside the case here. Well, I don't see much damage. I do see some rust starting to form already. Typically when it's fully submerged in the water, I don't get any rust buildup on this. It's usually when I pull it out of the water that all of a sudden I start getting corrosion building up on the blades and on the case and anything that has exposed iron in there. So one of the first things that we're going to do is go ahead and oil this thing up. Once we're done checking all the blades, let's go ahead and just rotate that real quick. Ooh, look at this, there is one little piece right here. Here we go. That was actually a little tiny sliver of what looked like to be metal. I'm kind of curious where that came from. Sticking right out there on the edge, just kind of going across two of the blades. That could be what we just heard scraping as I rotated it. So far I don't see any damage to the blades. None of the blades seem to be randomly spaced too far apart. None of the epoxy on the center core has come out. Alright, so the Tesla turbine looks like it's just fine after a quick examination. The only thing we're going to do now is we're going to oil this thing up, that way the erosion stops immediately. Otherwise, the longer this is out of the water, the thicker that rust coating is going to get on these laminates that we use for this. I'm also going to check the bearings, make sure they still sound like they're good. And that one's got a little bit of noise in it. We'll have to pack some grease in there, see if that'll help fix it. Let's go ahead and pull the back of the case off. Alright, this side looks a lot cleaner actually, look at that. Well, we might look at packing some grease in there. It does sound like it has a little bit of sound. A little drier than I'd like it to be. But overall, our Tesla turbine has once again proven that a very simple design made with the laminates from an electric motor can actually function, and not only function, but function year after year after year.